So now we'll look at a horizontal line, and what we're going to want to draw on a polar curve is going to be the polar equation r equals cosecant theta. Before you draw on a polar curve, it's going to help to see it as theta is one axis and r is the other, just like back basic trigonometry that we studied, where we looked at y equals cosecant of x. Just this right here. This is not the same as r equals cosecant theta. So we're going to fill in these values again. We're going to sketch it so that we can see. We don't really need the sketch here, okay? What we're more concerned with are all of these points, because these are the points that are going to allow us to draw our polar curve on the polar coordinate, because these are all of our polar coordinates that we've generated from this information right here, this graph. So let's grab all of these points. Remember, cosecant is just the same as 1 over sine of x. So we'll grab all of these points, write them down, and then transform them to the polar plane. So now that our coordinates are filled in, if we were to graph this, okay, we can make a quick sketch of this just so I can show you that your r in the table looks like the largest r is 2 and the smallest r is -2, but that's not the case. Remember, we only grabbed a tiny number of points. We only looked at a few thetas. Theta, we could plug in an infinite amount of theta. So let's get this graph of cosecant up there. So there's the sketch of cosecant, where theta's basically the x-axis, r is the y-axis, and we can see that the outputs, or r, go all the way to positive infinity, go all the way to negative infinity. So if we do like we studied when we looked at r equals secant of theta, if you wanted to see that r isn't just restricted to be between -2 and 2 here, we want something pretty close to 180 degrees. So why don't we also plug in 178 degrees, okay? And we'll do 1 over sine of 178 degrees, and we get 28.6 is r. So notice, it goes on to positive infinity, and also if I picked something on the other side of 180 degrees, like 182, we're going to get -28.6. So what we're going to do right now is now convert this to the polar coordinate plane so we could see what it looks like. So 0 degrees, r is undefined, so we can't graph that point. When r is 2, theta is 30 degrees. So 30 degrees rotation when r is 2, that puts us right here. 45 degrees, r is 1.4. So 45 degrees, 1.4 is about right here. 60 degrees, 1.15. 60, 1.15, even smaller. 90 degrees, r is 1. You should be noticing something. These are collinear. Let's pick another one. 2, 150. So r is 2, 150 degrees. Look at that. Those are collinear. All of these, 1, 2, 3, 4, 5, if I graph all of these, except for the ones obviously that are undefined, they are all going to be collinear. Now, you know the distance from 0 to this line. Okay, it's sitting right in this point right here, 1. So r equals cosecant of theta is the same as y equals 1 as a rectangular equation. So what we could do right now is we could do the same thing for r equals 2 cosecant of theta. And we can check to see what we're going to get. We know we're going to get a horizontal line, so why don't we predict what we think we're going to get here? Okay, make your prediction, and then we will see. So all we have to do is we have to take all of these values, the r values, from what we have as r equals cosecant of theta, and if we're doing r equals 2 cosecant of theta, we have to multiply all of the r's by 2. So that's going to give us some new points. So I'll make a few of the new points. Why don't we make from 0 to 180? So if we double those values that we had up here, okay, I'm going to sketch this in red. We could see at 30 degrees, R is 4. So R is 4. 30 degrees puts us right here. Next point, 45 degrees, R is 2.8, so R is 2.8. 45 degrees, right about there. 90 degrees, R is 2. That puts us right here. 150 degrees, R is 4. So 1, 2, 3, 4, 150 degrees. We've got a horizontal line. And if we converted that to a rectangular equation, we know what it is because that right there is a distance of 2. Constant line, horizontal. This is y equals 2. So, in general, if you have r equals a cosecant of theta, you're going to have a horizontal line that, if you write as a rectangular equation, would be y equals a. Now, you are responsible for seeing the polar equation and knowing what shape it's going to be and being able to describe the characteristics about it. So if you see r equals a cosecant of theta, you know it's a horizontal line and it's got a rectangular equation y equals a. If you saw r equals, just for a review, if you saw r equals a secant of theta, you know you have a vertical line whose equation would be x equals a. I just wanted to show you how you would plot these polar curves. You start, right, by drawing as theta is x, r is y, so you can grab all of those coordinate points r comma theta. That's how you would put them on the curve. But what you're responsible for is knowing when you see this that you have a horizontal line. When you see this, knowing that you have a vertical line. Next, we will look at another type of equation in polar curves.